I'm going to go over my Architect 2 assignment, building on my Architect 1 assignment from October. So just to bring everyone up to speed, if you hadn't checked out my Architect 1 assignment, this project is an ETL app, extract, transform, load, where you're able to upload a CSV file and the app will load that CSV file into a database, and it will parse that CSV file and put all the different CSV segments into database entries. I guess the different comma delimited sections of the CSV will be like different columns and different entry columns in the database. And then once you've updated it, you'll be able to see your history of files that you've uploaded, including the file name, the date that you uploaded it, size of the file, actual size of the file, and whether or not it uploaded successfully or not. And then if you want, it has this sort feature, or you can look at it a different way. Instead of ascending order, you can look at it in descending order. So I'm going to go into the hood and I'm going to show you a little bit how this feature of the app works. So all these values are originally seeded into the database by this database seeder class, which, because it is of type application runner, will run as soon as the server application starts running. And I'll show you here, right on load, you'll have this uploads table available in the database with all the data that you saw in that history table, or that history panel, the client of the app. So once it actually goes in the database, and by the way, this is the same database that you're able to upload your own CSV. Your own CSV will go up into the same table of uploads, but your actual entries will be in two other tables, which I'll get to in a little bit. It will be inserted into this red-black file system. Red-black file systems are commonly used to store files on like a desktop computer, your laptop. You'll have a red-black file system as the data type to store that kind of information. It's a tree structure with nodes. You can already see the first insert method in this red-black file method allows you to insert nodes in a recursive way. Here's the other function for inserting that nodes. It'll start with a null, but as soon as a new node is inserted into the database, it'll keep on going left, right, depending on some logic that I've defined down here. I went with timestamp, so it'll get sorted, I guess you could say, left, right, depending on whether or not the timestamp is before or after the node before. And then the unique thing about the red-black file system is, let me pull up the node class, it's also given a red value. And without going into too much detail about how it works, there will be red nodes and black nodes. There will be, no matter what side, left or right, the same number of black nodes to traverse until getting to the root node. And that makes sorting it a lot more efficient. The only problem being when you're inserting nodes to make sure that the red and black alternate, so that you will have the same number of black nodes to traverse to the root node. There's a lot of rebalancing that goes along, or that is involved in that. And so, as you can see in this insert method, there's this rebalanced method, and that rebalance method carries all the logic for transforming the nodes you already have in the tree so that it can meet that criteria that I just talked about. So that there's the same number of black nodes from the null nodes at the bottom to the root node at the top. And it all really has to do, or the way that you rebalance it, it all has to do with the three cases for how it can become out of balance, so that you can't do that balanced traversal from the null nodes at the bottom to the root nodes at the top of black nodes. But also, like, there's like rotations, like 3 node rotations that keep it in balance. You can go right or left. But right here is all the logic that allows it to be balanced, so that when you want to display it in through an in-order traversal, which means that you'll be able to display the nodes one by one in order, it'll always work, and it'll always be taking advantage of that red-black tree efficiency. One thing that I do want to show you about this tree, because it's important, remember how I was able to display the results that are kept in this tree that have been inserted from the database in reverse order and regular order? Well, displaying the results in reverse order is just as simple as traversing the red-black tree from right to left instead of from left to right. So these red-black trees are very easy to sort data either ascending or descending, again, in a pretty efficient way. So I'm going to show you the service that I use to insert the database values directly into the red-black tree. You'll notice I've auto-wired in this dependency, this upload repository. This takes care of all of my inserts and all of my changes to this uploads table. And then also I have to have the red-black file system, or at least an instance of that red-black file system in this service. And all it does is it runs a simple find all from that user repository, getting all of the records into a collection, and then using a for each to go through every single one of those records or uploads in the collection, and just doing file system insert. And you do that one by one, and the recursive method in red-black file system will put it all in order and rebalance it every time. So you always have a perfect red-black tree. So the last piece is actually returning the list from the red-black tree, specifically this file system instance that I've created. So all that's required here is, depending on whether or not it gets passed an is_reverse argument, it'll either return the file system traversed in reverse or the file system traversed in order. And then, of course, this is all going over the network. I'll just show you the controller real quick with both of those operations working over the network depending on requests. So you'll get a post request from that button that will either switch is reversed to false or is reversed that's already false back to true. And then based on whatever it gets in that post request, here it is down here, it will change the is reverse variable in this class. And depending on what the is reversed variable is set to in this class, it will print out either the reversed or in order list with this create upload list method. And that, of course, the create upload list method in the upload list service just takes is reversed as an argument, and then it'll give you the list in reverse or the list traversed in order depending on what that argument is set to. Now, one thing that was kind of difficult about building this feature is that, let me open up this, the order that the application seeds the database and the order that the nodes get inserted into the database matter. The issue that I was having is this service that inserts the database, or sorry, that inserts the database records into the black-red tree was running before the records were even seeded into the database. So what I had to do to get around that is create this event listener that is connected to this database seeded event class in my database seeder. And basically what that does is it uses this method down here, this publisher method that is part of this application event publisher class, to make like a change record or update this database seeded event that both database seeder and the RBT service have access to, so that this method doesn't run until after the database has been seeded. And you can kind of see how it's tracking that. You have the database records go in there, and then the file system gets inserted. And there might be like onesie, twosies that don't quite go in right. But theoretically, that's supposed to happen exactly after. And, you know, these operations are happening milliseconds apart. So you have to be very careful the order that you do these things in, especially when I'm using this post construct annotation and the database seeder is using application runner as its type. So these are running supposedly immediately once the server application starts. So that's how I have this feature of the application running. In the next video, I'll be talking about how the CSV file gets uploaded into the database, parsed, and put into different entries.